Assalamu alaikum, my dear students. How are you? Hope you will be fine and okay. Uh, I welcome you all into my today lecture. Our today lecture is the about unit number 16. Lecture is 34, and it is the classification of solids. So here this is rather you can say the kind of a solid state physics. Here in this physics, we will study about the mostly the physical properties of the solids, right? That what happens to the solids when they're, for example, when they are under pressure or when their temperature is changed or like such properties. So we will study about this. Here we will study about crystals, types of crystals, polycrystalline solids, amorphous solids, and the crystal structure. So first, crystal. Let me introduce to you to the crystal. Crystal, a solid body bounded by natural plane faces that are the external expression of a regular internal arrangement of the constituents such as atoms, molecules, or ions. So you see here, look, for example, here we have the quartz crystal, and here you see, look, this is the each face of the quartz crystal as you see here, like this. So this is what the solid that is bounded by the natural plane faces that are the external expression of the regular internal arrangement of the constituent atoms, molecules, or the formation of the crystal by substance passing from a gas or liquid into a solid state. Here we have the sodium chloride crystal also. As you see, this is the sodium chloride crystal, example of the sodium chloride crystal. Now, crystal differ in physical properties. There is the hardness, that how hard they are, the cleavage, and the optical properties such as the heat conductivity, electrical conductivity, of which we are which are of great importance for us. These properties are important since they sometimes determines the use to which the crystal are put in an industry. For example, crystalline substance that have special electrical properties are much used in communication equipment. These includes quartz, for example. Here other examples are also there. For example, we use diamond crystal to cut glasses due to because of its hardness. So these are the various properties of the crystals. So and now, as I told you, that we will study the types of the uh, crystals, and as I told that we have the crystalline solids first. So let me explain to you about the crystalline solids. Crystalline solid. In crystalline solids, the particles that are atoms, molecules, ions, they are arranged in a definite geometric pattern in three-dimensional network. So we have a 3D geometric network. For this 3D geometric network of the molecules are atoms. What does this mean? That in crystalline form or in crystalline solids, they have definite geometric patterns or shape. Definite geometric, definite geometric pattern or shape. As you see here, for example, in this case, in the case of the sodium chloride crystal, you see here a cubical shape structure like this one. For example, here you see, look, this is the sodium chloride crystal. You see here the chlorine atom, and you see here the sodium atom. Now that is the we this definite geometric pattern, we sometimes call it the long range order. The long range order, it is called what? The long range order. So they have a definite geometric pattern or shape which repeat itself continuously, repeat itself continuously over the entire crystal. So this arrangements is, there is a periodic repetition, or you can say that the arrangements repeat itself here. The arrangement repeat, the arrangement repeats itself periodically, itself throughout the entire crystal or over the whole crystal. For example, you see if this is the basic cubic crystal structure. So you see here that this crystal structure repeat itself continuously like this, and then this like this. So the structure repeat itself in a 3D plane. They have smooth face and straight edges. In crystalline solid, they have smooth faces and very straight edges, straight edges. You see here, look, they have very straight edges. Here I will mark the edges, right, and they have a very smooth face also. As you see the smooth face here, look, this is the smooth top face of the structure. We can study the properties of the solid. You must remember that solid, they can be studied by what? By X-ray diffraction, right? By X-rays probe or diffraction, which you studied in first year. Because of the its extremely small wavelength, it can easily penetrate into the crystal structure and can reveal the greater detail about the structure of the solid. So X-rays are used to do this. That we call the arrangements as order. The arrangement of the atoms, the arrangements of the atoms in the solid is called order. So the crystalline solid have definite order shapes, right? They have what? They have the different order shape. Crystal possesses both short range and long range order. It possesses what? The possesses both long range and short range order. For example, as I told you about the quartz crystals, the diamond crystal, and the sodium chloride. This is quartz crystals, quartz. And here we have the sodium chloride crystal, right? As you see it of the types of the crystalline solid. Now we have the polycrystalline solids. The polycrystalline solids. Polycrystalline solids. In the polycrystalline solids, the polycrystalline solids are the kind of material made up of many small single crystal called the grains. They are called what? They are called the grains. Small consist of what? Consists of small single crystal. Small single crystal called grains. Called the grains. This is the best example of the polycrystalline, right, as you see here. So they consist of like small crystals. We call them the grain. I am giving you another example. Look like this one, like this. Here you see we have the carbon atom, and here we have what? And here we have the hydrogen. This is most probably the ethene structure, like that. In this repeat itself like this, like this, like this, like this, and so on. And then when it just goes on, or when they added up, they will give you the kind of what? The polythene crystals, right? So when you combine them, so like when you combine them, they will form, as you see here, the combined shapes of those small crystals. So they will just look like this, and look like this, again, this. So this is the example of the polycrystalline solids. The polycrystalline solids, they, as I told, consist of the fine grain which has the size of 10 to the power 4 and strong, or that is these which are separated by well-defined sharp boundaries and oriented in a different directions. So that is what I already told, that single crystal, right? We call that the grain. The shape are here in the solid, there were regular shaped. I might use the word regular shaped here also. Regular shape. And here for the polycrystalline, the shapes is totally irregular. They are irregular shaped. Irregular shaped. They have well-defined boundaries and oriented in different direction, and each grain is a single crystal of the irregular shape. It is the isotropic in nature. Isotropic in nature means that they have the same properties in all direction. In these kind of solids, the ordered regions vary both in size and orientation. Ordered region varies both in size and in orientation. Okay, like you may say, like let me write like this way. For example, like this, like this, like this, like this. So they varies in shape and orientation. There is no particular orientation which we can say that the crystal is oriented in this direction only. There is the grain has boundaries also, called the grain boundaries. Boundaries, these are called the grain boundaries, right? As you see here. So each grain is separated by a boundary called the grain boundaries. The size of each grain is of the order of 100 nanometer to 100 micrometer. That is the size of this. The third one is the amorphous solid, right? Like this one. Class, I'm very sorry for my writing. There is pain in my shoulder, so I'm not comfortable with it today. The amorphous or the non-crystalline solid is composed of randomly oriented arrangement. There is no definite order shape. There is what? There is no definite order shape. Bas, no definite order shape. Right? For example, the polycrystalline solid lies between order and disorder, while it purely acts like a very disorder arrangement, you may say. The atoms, ions, or the molecules do not form definite patterns or lattice structure. As you see, the particle, and look, this is the example of the cotton candy for the kind of the amorphous solid. Here you see. So in the amorphous solid, the arrangements of the atom is random. Random arrangements of the molecules or atoms in the given substance. That is the example I would like to tell you, that some liquids, when cool, they become more and more viscous and then rigid, retaining random atoms characteristics, right? Like, for example, I would like to tell you is that of the glass. Okay, so they such kind of substances, they do not have definite melting point, melting or boiling point, melting or boiling point, right? So the best example for this I would like to give you is that of the glass or rubber, are the best example of such such amorphous solids, right? So So we have these three kinds of the types of the solids. That we have the crystalline solids, we have the crystal solids, and we have the amorphous solids, right? And about the shape and what is the next topic? The amorphous solid, the crystalline structure. So the crystalline structure, I will explain it to you, inshallah, in my next lecture, right? That I will tell you about the crystalline structure. That what is the crystalline structure? Crystalline structure is in fact when basis is added at each point in the lattice, then this form the crystalline structure. So I will explain the crystalline structure in greater detail in the next coming lecture, right? When scheduled. Thank you very much for being here today.